Welcome to the first outcome, where the aim is to turn a set of numbers into a picture. We'll build stem and leaf diagrams and box plots by hand, then learn to read off their shape, their skew, and any outliers. Let's start with what we mean by a distribution. It's simply how a set of data values is spread out across its range. The whole point of a diagram is that it lets you take in the center, the spread, and the shape all at a glance, without listing every single value. Everything here works on a single set of numbers, and we're always aiming to describe that data clearly and honestly. There are really three things a good diagram should reveal. First, the center, roughly where the middle of the data sits. Second, the spread, how widely the values are scattered. And third, the shape, whether the data is fairly symmetric or stretched off to one side, which we call skew. On top of that, keep an eye out for unusual values sitting far from the rest, the outliers. A stem and leaf keeps the actual figures, while a box plot boils them down to a summary. A few words to get straight first. A distribution is the pattern of how the data is spread. A stem and leaf diagram splits every value into a stem, the leading digits, and a leaf, the final digit. So the stems run down the left, the leaves sit beside them, and a key, something like a stem of 4 and a leaf of 2 means 42, tells the reader how to decode it. So how do we actually build one? For two-digit data, the stem is usually the tens digit, so you write those tens digits in a column down the left, smallest at the top. Then each value's final digit goes in as a leaf beside its stem. Once they're all in, order the leaves along each row from smallest to largest and add your key. Keep the leaves evenly spaced, because then the length of each row shows you the frequency at a glance. Let's build one. We've got 12 test marks out of 90, 42, 45, 51, and so on up to 83. The tens digits give us stems of 4, 5, 6, 7, and 8. In the 4 row go the leaves 2 and 5, so a stem of 4 with leaves 2, 5. The 5 row takes 1, 3, 8. The 6 row 1, 2, 7. The 7 row 2, 4, 8. And the 8 row just a single 3. Line those up and you've a neat ordered stem and leaf. With the key, a stem of 4 and a leaf of 2 means 42. Once it's drawn, a stem and leaf tells you a surprising amount. The longest row shows where most of the values cluster. That's your modal class. Counting all the leaves checks n, the number of values. Because the data stays in order, the median is easy to pick out, and the smallest and largest values are just the first and last leaves. And a tail of short rows trailing off to one side is your first hint of skew. Reading our diagram back, let's pull out a few facts. Counting the leaves, 2 plus 3 plus 3 plus 3 plus 1 gives 12, so n is 12. The smallest value is the very first leaf, a stem of 4 and leaf of 2, so 42. The largest is the last one, 83. And the longest rows are the 50s, 60s, and 70s, which each hold 3 values, so they tie as the modal class. Now for box plots, which need their own vocabulary. The median is the middle value in order, sometimes written Q2. The lower quartile, Q1, sits a quarter of the way through the data, and the upper quartile, Q3, 3/4 of the way through. The gap between them, Q3 minus Q1, is the interquartile range, the spread of the middle half. And the whiskers are the lines running out to the smallest and largest values that aren't outliers. To find those quartiles, first put every value in ascending order, that's essential. Then the median sits at position n plus 1, divided by 2. The lower quartile is at n plus 1, divided by 4, and the upper quartile at 3 times n plus 1 over 4. If a position works out to a half, you just average the 2 values on either side. Together, those 5 figures make up the 5-number summary. Let's try it on 11 values, already in order from 3 up to 20. With n equal to 11, the median position is 11 plus 1 over 2. That's the 6th value, which is 10. The lower quartile is at 11 plus 1 over 4, the third value, so 7. The upper quartile sits at 3 times 12 over 4, the ninth value, 15. And the interquartile range is Q3 minus Q1, 15 minus 7, which is 8. Drawing the box plot itself is straightforward. Set up a scale covering the smallest to the largest value, then draw a box from Q1 across to Q3, with a line inside marking the median. Extend whiskers out to the lowest and highest values that aren't outliers, and plot any outliers separately as crosses beyond the whiskers. Label your axis so the readings can be checked, and remember that box holds the middle 50% of the data. Taking the same 11 values, let's list the 5 numbers we need. The smallest is 3 and the largest is 20. From before, Q1 is 7, the median 10, and Q3 15. So the box spans 7 to 15 with the median line at 10, the left whisker reaches down to 3, and the right whisker out to 20. There are no outliers here, so that's our full 5-number summary: 3, 7, 10, 15, 20. So how do we decide what counts as an outlier? The standard tool is the 1.5 times interquartile range rule. You work out a lower fence at Q1 minus 1.5 times the interquartile range, and an upper fence at Q3 plus 1.5 times the interquartile range. Anything below the lower fence or above the upper fence is flagged as an outlier, and on the box plot those points are drawn separately, out beyond the whiskers. Let's test whether 45 is an outlier in this set of 9 values. The median is the 5th value, 18. For Q1, the position is 2.5, so we average the second and third values, 14 and 15, giving 14.5. For Q3, we average the 7th and 8th, 20 and 22, giving 21. So the interquartile range is 21 minus 14.5, that's 6.5, and 1.5 times, that is 9.75. The upper fence is 21 plus 9.75, so 30.75. Since 45 is well above that, yes, it's an outlier. Let's talk about shape. A distribution is symmetric when its 2 halves roughly mirror each other. If instead there's a long tail of higher values, we call that positive, or right skew, and the mean usually sits above the median. A long tail of lower values is negative, or left skew, with the mean below the median. In short, skew just tells us which way the data has been stretched. Let's put the 2 kinds of skew side by side. With positive, right skew, the longer tail is on the right among the high values, the median sits closer to Q1, and the gap from the median up to Q3 is the bigger one. Incomes are the classic example, where a few people earn a great deal. Negative, left skew is the mirror image. The longer tail is on the left, the median sits closer to Q3, and the gap from Q1 up to the median is larger. Exam marks where most students score highly often look like that. So to read skew straight off a box plot, compare the 2 halves of the box, the median minus Q1 against Q3 minus the median. Whichever gap is bigger points towards the tail. Then check the whisker lengths as a second clue. If both the gaps and the whiskers are roughly equal, the data is fairly symmetric. And do be careful, a single far-flung point is an outlier, not skew on its own. Here's a box plot with a minimum of 15, Q1 at 20, median 25, Q3 at 40, and a maximum of 60. Let's describe it. The median minus Q1 is just 5, a short left side of the box, while Q3 minus the median is 15, a much longer right side. The left whisker is 5 and the right whisker a full 20. Both the box and the whisker are stretched towards the higher values, so this distribution is positively, or right, skewed. Let's pause and check a few things. In a stem and leaf diagram, what does the leaf represent? Can you write down the formula for the interquartile range? What's the upper boundary you use to test for an outlier? And if the gap from the median up to Q3 is much bigger than from Q1 up to the median, which way is the data skewed? Have a think before we carry on. it's worth weighing up the two diagrams. A stem and leaf keeps every original value, which is lovely for small to medium datasets. It shows the shape and lets you read off the median, but it gets crowded once the data gets large. A box plot instead summarizes everything into 5 key numbers, which makes it ideal for comparing 2 or more groups and for showing skew and outliers clearly, though the price is that it hides the individual values. A few common slips to steer around. Always order the data before you go hunting for quartiles. Never leave the key off a stem and leaf diagram. Take care to use Q 1-1.5 times the interquartile range for the fence, not just Q 1 minus the interquartile range. Don't read a long whisker as the wrong direction of skew, and don't treat a single outlier as proof of skew. And keep your spacing even, or the row lengths will mislead the reader. Let's pull it all together on 9 values from 21 up to 41. The median is the 5th value, 27. Q1 is the average of the 2nd and 3rd, 23.5, and Q3 the average of the 7th and 8th, 32. So the interquartile range is 32 minus 23.5, that's 8.5, and 1.5 times it is 12.75. The fences come out at 10.75 and 44.75, so there are no outliers. Comparing the halves, the right side of the box and the right whisker are a little longer, so we've a slight positive skew. One more quick check. Can you list the 5 numbers you'd need to draw a box plot? For 13 values, which position gives you the lower quartile? If a dataset has Q1 of 10 and Q3 of 22, what's the upper outlier boundary? And can you name one advantage a box plot has over a stem and leaf diagram? Take a moment with those.